This video was created by Danny Kessler, Associate Professor and Korea's first PhD in wellness tourism. Look at an average day in a dense metropolitan area like Seoul. You have multi-lane, gridlocked traffic surrounded by towering commercial infrastructure. All of this concrete and exhaust creates a concentrated zone of heat and emissions that drains your physical energy before you even reach the office. Urban planners call this the heat island effect. Concrete and asphalt absorb solar radiation and trap it, making city centers hotter than surrounding areas. For decades, city dwellers have treated the resulting stress and physical exhaustion as an unavoidable tax on city living. But the resulting chronic cognitive fatigue we experience in dense populations is not a requirement of modern life. It is the result of a specific architectural design failure. We have historically operated under the assumption that repairing this daily physiological damage requires escaping the city for expensive, isolated natural destinations far outside the urban grid. This graph plots cognitive fatigue over time based on the 2030 predictive model. It tracks neuroarchitectural data, showing a sharp downward trend in neurological strain when entering a restorative environment, compared to the sustained high fatigue in passive city streets. The data proves that isolation isn't the key factor in recovery. The data suggests that the structural environments we build can be engineered to actively repair the human nervous system as we walk through them. We now have the technology to re-engineer a standard transit route to serve as a clinical-grade intervention. By treating urban environments as tools for physiological recovery, the traditional urban commute is reclassified from a transportation issue into a measurable public health hazard. Seoul's northern district of Gyeongbokgu is currently deploying a blueprint that addresses this hazard directly. It is called the 𝗨𝗶𝗿𝗀 integration, and it establishes a specific standard for future smart cities. This map shows the exact spatial layout, highlighting the boundary between the urban grid and protected forest canopy. Zooming in on specific nodes along this 700-meter sensory pathway reveals a sophisticated hardware layer, hyper-advanced IoT infrastructure embedded directly into ancient stone and copper architecture. These embedded sensors operate continuously, pulling real-time ambient ultraviolet data and tracking minute-by-minute temperature fluctuations in the air. The architecture here is entirely active. It functions as a predictive machine that constantly monitors the environment for thermal hostility and prepares to counter it. When those sensors detect that the urban heat island effect has spiked beyond a safe physiological threshold, the system executes an automated trigger logic. Solar-powered automated smart shade canopies mechanically slide closed beneath the natural forest canopy, linking up with a localized automated steam release. This immediate environmental output creates a dense, low-lying thermal barrier. The pedestrian is now physically shielded from both the overhead sun and the radiant heat of the adjacent concrete. The specific physiological goal of this system is to artificially lower the commuter's core body temperature during their transit. By cooling the body, intervening before cognitive fatigue sets in, engineers produce rapid psychological grounding rather than leaving health to chance. This map illustrates the district-level deployment of the system. By installing these automated cooling stations at specific boundary points, where urban concrete intersects with natural forest canopies, planners have established a scalable network of clinical transit corridors. This allows the city to deliver clinical-grade natural air and targeted cooling directly to dense populations within their existing commute. Most importantly, commuters receive this intense, targeted thermal regulation naturally on their way to work, without ever having to leave their specific zip code. This proves that biological recovery can be delivered at scale, directly integrated into the daily transit matrix, addressing the systemic stress caused by extreme urban density. As global climate volatility increases and heat waves become more severe, this kind of protective, responsive infrastructure will move from a luxury to a requirement of urban planning. We are approaching a point where cities will no longer be judged solely on how quickly a train moves from point A to point B. Instead, the measure of urban success will be biological impact metrics, specifically how effectively the physical environment sustains and repairs the human body. The passive city is no longer a viable model. We are now seeing the emergence of the restorative metropolis. This video was created by Danny Kessler, Associate Professor and Korea's first PhD in Wellness Tourism.